Alrighty, CNT125, our module on design, network design. This is serving two purposes. One, refresh your memory of quite a few concepts we've covered in 120 and 125. And two, bring all those to the surface so they're fresh in our head so we can tackle our design lab. And the focus of our design lab is really to pull all these pieces together we've learned in 120 and 125 into a functioning working network for I'm using little air quotes here, for our customer. So let's do that. Let's barge right in here and kind of jog our memory on quite a few things we should remember. First thing, topology. What topology should our Ethernet network, topology should our network be? Well, if you remember from our standards, whether it be cabling or IEEE for our network, star topology. So as I'm hooking up my equipment, I'm thinking devices into their individual switch port. If I have multiple switches around the building, those switches connect into a central layer 3 switch or device in the middle of the network. So I'm thinking star topology. And I'm mentioning that so we don't think of odd ways to hook up our equipment we haven't done before. We keep doing it a certain way because that is the norm, that is the standard, that's how things are typically done. Here's a reminder of your cabling standard about what they're calling for. Horizontal cabling should be star topology. It's mainly for our cabling people, but connecting the dots for you. What type of design should be used to connect our devices? Again, we're thinking star topology, but think a little bit bigger now. Hopefully you remember, this was back in, I think it was chapter 7, the different layers, the Cisco 3-tiered architecture, access distribution core layer. This is here for a reason. This is a guide of like, hey, this is how I typically hook my equipment up and what role they'll serve in that part of my network. So the access layer is really our layer 2 mostly access switches that are connecting our hosts. And it could be connecting computers in, phones in, printers in, access points in, etc. Any of those access devices would be connecting into our access layer switch. That's these right here. So our ordinary, run-of-the-mill layer 2 managed access layer switch, workgroup switch, if you will. Then there's typically a distribution layer. This is usually a mesh of typically like layer 3 switches that are going to connect these layer 2s together. So right here would be distribution layer. Now, you can think of this as these are a couple switches on one floor of a building, and the distribution layer switches are connecting those together. So I would have maybe 2 or 3 closets on a floor. This layer 3 switch is going to interconnect those. Excuse me. And then there's typically a core layer. And this might be, again, upper layer switches or routers that are interconnecting those floors or closets in a building. Okay, these up here, layer either, maybe a layer 4 switch kind of thing, or potentially a core router to interconnect all of that. Now, the reason they're mentioning these is I should be designing my equipment to fit one of those layers, and one of those layers has kind of like a norm set of rules that you're doing. So if I think to just this example here, these layer 2 switches are access to the network, but also doing things like VLANs, separating our groups of things or populations in our building, this department or this group or this type of equipment, etc. Up here, distribution layer, we're now starting to implement usually some subnetting, maybe some inter-VLAN, maybe some filtering with access lists, that kind of thing. Okay, so when we're thinking connecting our network together, we're starting to think of there's a model or architecture that we're aiming for. Also, back in layer 7, they said, well, in modern networks where we started introducing more cloud technologies, this might get shrunk down a little bit. So I still have these 2 layers, but the actual kind of like the core layer ends up being out here, which is connection to the outside. So your structure might be collapsed a little bit, but you still have layers doing a specific function. When I'm talking about connecting my closets together, those are typically my backbone links. So with my backbone links, I'm thinking a couple things. One, the standard still calls for star topology. So I'm still connecting, I'm going to back up here a little bit, I'm still connecting my closets together with a star topology. My workstations here into the switch, a star, and then multiple switches into layer 3 switch, that's still a star topology. Again, I'm not linking things together in a daisy chain or ring or anything odd like that. I'm sticking with kind of the norm, what it's called for. They also say no more than 2 hierarchical layers, and that's kind of what we're seeing back here on this design as well. Okay, here is basically our here's our 2 layers, and then the core layer tying them together. Okay, so I'm not going to keep stringing this on and on and on, is what they're getting at. When I'm dealing with my backbone links between closets or between switches, what are some bandwidth considerations? Hopefully you remember this from when we talked about switches in 120. If I have switch ports connecting desktops at 100 meg, the uplink port between my switches should be at least a gig. If I'm running gig to the desktop, then the uplink between the switches should be at least 10 gig. And we're getting at this concept here. These are the user ports over here that workstations or phones plug into or switches plug into. If these are 1,000 meg ports or gig ports, then this uplink, okay, this uplink here that I use to connect to another switch or another closet, this needs to be a larger factor. And you're typically doing a factor of 10 above. That's typically how these are done. So over here, if these are gig ports, this port here connecting to the other closet or the other switch should be a 10 gig port. Should be a 10 gig port. So as I'm looking at switches, I'm looking at that. I'm looking at what spec are these ports and these uplinks over here, what are they capable of? Well, these are SFP slots that are 10 gig, and this is where I could plug my SFP module into. Okay, so hopefully that jogs our memory from like chapter 5 back in 120. Virtual machines, what role are they going to serve? Think about when I'm starting to add servers into my network. I'm typically going to be, now we used VMware Player to make a virtual machine in our lab room, but in real life you're most likely putting that virtual machine on literally the host OS, VMware ESXi kind of thing. And now I could have multiple virtual servers sitting on this physical server box. So virtual machines are playing the role of like the servers that I need in my network. And they might be my DNS server, they might be my DHCP server, those kinds of things on my network, email server, etc. They would probably be in this manner, created in this manner for devices to access it. Collision domains, and for that matter, broadcast domains. Collision domains, hopefully you remember, back in the early days of Ethernet, we had the bus topology where everybody was competing for the bandwidth. As we moved into hubs and switches, the switches having some intelligence were able to create a collision domain per user because the switch port is allocating essentially a full bandwidth to each switch port. So the switches are designed to connect two nodes directly so that the communication is going directly between those two switches, and they're not competing for bandwidth with anybody. They're not competing with anybody for bandwidth. So moving away from hubs into switches, we are creating this dedicated bandwidth for each port. So in our networks today, we have pretty much all switch network because of this concept, trying to get full bandwidth to every user. So that's kind of like that's how we ended up where we are, and we keep that in mind. We're not going to do anything strange outside of that plan, if you will. And broadcast domains, this is the area where broadcasts can propagate. So we're thinking, how do I contain those? Well, things like routers will contain those broadcasts. So a broadcast were to be emitted over here, these switches would pass them on, and once it hits the router's going to wait, hold on. I'm not going to pass that to another part of my building. So anything router or layer 3, could be a layer 3 switch, can create these broadcast domains. The other piece of that, hopefully remember, is VLANs create broadcast domains as well, which is one of the reasons we create VLANs around populations or types of equipment. My IP phones get a VLAN, my wireless users get a VLAN, maybe my desktop users or this department gets a VLAN, and that helps contain these broadcasts. Which brings us to VLANs. How about that? VLANs, what are they? What are we creating them on? Well, we're creating them by switches. We're creating them on typically your switches. And these are here for broadcast containment and a form of security. So in this was a picture the book used. You can group users across different floors and different switches into a VLAN. I just take a little bit of configuration. So I can have maybe a department that's spread across multiple floors. I can take all those departmental computers and put them in their own VLAN. Or I can do something like all the employee desktops go into VLAN, all the employee phones, IP phones go into a VLAN, all the wireless access points go into a separate VLAN, and that way these populations of equipment are separated out. And our VLAN trunk, remember, VLAN trunk, when I interconnect switches, the trunking is there so that traffic here from VLAN 10, as it goes into the switch, can get tagged. That's what the trunk does. The VLAN 10 traffic gets tagged, so when it gets to this switch, the switch knows, oh, I'll pass that out of VLAN 10 port, but no other port. So the trunking is going to institute the VLAN tagging. And the VLAN tagging is there so when that traffic gets to another switch or a router or another device, it knows, okay, this belongs to VLAN 10. I can forward it onto a VLAN 10 port or device, but anything else I'm not going to do. I'm not going to let that happen. So the trunking is allowing this kind of thing to happen. And also, as we'll talk in a minute, with the inter VLAN. When we talk VLANs, we also need to talk IP management, subnets. Hopefully remember when we learned back in Chapter 8, we talked VLANs, we configured them, we talked subnetting, we worked on that, and then we put the two pieces together. Well, typically, when I have a large network and I start creating VLANs to divide my users up, those are going to get accompanied by a subnet. Pretty much a subnet by VLAN, per VLAN. That's the generic rule that you do. So as I start creating VLANs for my different types of users, I'm also going to be creating a subnet for them. So that they're now divided at layer 2 with VLAN and divided at layer 3 with the IP subnet. So now I can start doing things like this. You know, maybe users in this floor in their own subnet, users in this floor in their own subnet, etc. But I can even go further with the VLANs. Now, as I talk IP management, these things pop up too. Private addressing, NAT, DHCP. How are these useful? Well, think back to private addressing. With private addressing, whatever my ISP gives me, I can convert into a private address scheme inside. And the private address IP scheme inside allows me some flexibility. I could select a 172, I could select a 192, and have that number scheme to subnet to grade the subnets per VLANs. And I could do that organization that I need to do independent on what the ISP gave me for numbers. And then I can take that private scheme inside, in this case they're using a 10, and I can translate it to the IP address that the ISP gave me. So with using NAT, I can translate whatever the ISP is giving me into whatever private scheme I want to use inside. Hence these two kind of go together. Private addressing and NAT tend to go together. Well, the third piece of the puzzle is I typically don't want my users having to plug static IP addresses in, so I then configure my network to hand out IP addresses to the users with DHCP. And as we've done, we've configured the router to have DHCP, but I could also have a separate virtual server running, ESXi server running to hand out IP addresses too. I could do that as well. But we've been using the router and having the router do DHCP for the clients so they're receiving the correct IP for the group or subnet that they're in. And as we've seen, we can have it where the phone gets one subnet and the PC in that same office gets a different subnet IP. And that way those two devices are separated from step one. So all these tend to go together hand in hand. I'll NAT whatever the ISP gives me into whatever private scheme I want to use, organize and subnet it how I need it, and then I can have my server or my router do DHCP and hand out IP addressing to these different populations so I have control over what they get. And then that leads us to inter-VLAN routing. So I have the VLANs, I have the subnets. I can now configure the router or something layer 3, could be a layer 3 switch, to recognize all those and allow communication between those VLANs. Or I can limit them through access lists and filter the traffic that moves between those VLANs, which we have done both. When we first did inter VLAN, we allowed all the traffic to flow, and we saw the traffic literally go to the switch, to the router, and then back to, the next device. But then we also learned that we can put an access list up here to filter the traffic, that these populations, the employee computers don't get filtered, but the visitor laptops, if you will, get highly filtered. We can do that because we've separated it layer 2 with VLAN, layer 3 with IP, and we've told the switch to trunk that traffic and the router to recognize those trunks, those VLAN tags. And then we told the routers to do, let this happen or don't let this happen. And it's now filtering the traffic from these different VLANs and different subnets. So all these are playing a vital role in organizing and kind of sorting out our network and setting up for some security.